In this video, we're going to change the order of integration in order to evaluate this triple integral. So looking at this, you don't really want to integrate this with respect to y first, because you've got y squared and y squared. X is relatively easy to integrate, but if you do it with respect to dz first, then you can treat this whole block as a constant. So later when you integrate it, it will just simply be this. So rather than integrating in this order, let's integrate it with respect to z first, and because we know that y is going to be complicated, let's leave it to the end and then integrate the dx after the dz. But then in order for us to change our order of integration, we need to understand the region in which we're integrating over. So let's sketch this thing. Hang on, sketch it so that we can change the order of integration. So this would be x, y, and z. So looking at this, it would be x equals something, x equals something, y equals something, y equals something, z equals something, z equals something. We're looking at the inner integral. You're moving parallel to the x direction, and then you're integrating from 0 to natural log of 3. So you're integrating from x equals 0 to x equals natural log of 3. So let's just imagine this is natural log of 3. And in terms of the y, so that means you're moving parallel to the y-axis. You're integrating like this, you're moving parallel to the y-axis, and then you start at this, and then you end at y equals 1. Well, I don't know what this thing looks like, so let me just cube both sides. So that will then give us this, and let's visualize the 2D version, the z versus y-axis, and this is going to be a cubic. So what that means is on the 3D diagram, it will look like this. It will be some sort of cubic like this, and then along here you're going to get another cubic, because this equation, there is no x in this equation, so you're going to get a trace along the x-axis. So this is like a surface here. This thing here would be a surface. So hang on, and so hang on, let me think. So this is your x. So let me just draw the region. Hang on. You're looking at the y. You enter the surface, and then you leave y equals 1. So let me just imagine this to be y equals 1 here. So hang on. So y equals 1. So you're going to get this thing here. So this is like your vertical rectangle here, and then you've got cubic here and straight across here. So let me just erase this and erase this. So this is natural log of 3. So so your region is really this skateboard ramp. So imagine this is a skateboard ramp. So you're skating along, and then you hit the ramp, and then you shoot up. So it's like a skateboard ramp in the shape of a cubic. So this is a cubic. You've got to imagine this is a cubic. So now that we know our region looks like this. We can now change the order of integration. So now that we know our region, remember that this surface here is your skateboard ramp surface, and it's given by this. So looking at the inner integral, we want to change the order of integration from here to here. So in the inner integral, we're doing it with respect to z first. So you enter z equals 0, and then you leave the surface, which is this thing here. You enter a z value of 0, and then you leave the surface. You enter z equals 0, and then you leave the surface being y to the power 3, y to the power 3, y to the power of 3, and hang on. So if you're doing it with respect to z first, you enter z equals 0, and then you leave the surface. And then once you've taken care of the Z, then our domain, our region, our 3D region will lose one dimension. It will lose the Z dimension. So this 3D solid will lose the Z dimension. So the 3D solid will get flattened down to this sheet of paper here, to this 2D sheet of paper, because we've taken care of the Z, so we lose one dimension, the Z dimension. And then looking at the X, you're moving parallel to the Z-axis, so you enter x equals 0 and then you leave natural log of 3. So you enter x equals 0, you leave natural log of 3. And once you've taken care of the x dimension, then this 2D sheet of paper will lose one dimension. It will lose the x dimension. So it's going to get flattened down. It's going to get flattened down to a line, because it loses one dimension. So now you've just got this thing here. So in terms of the y, because you're moving parallel to the y-axis, you're actually integrating from y equals 0 to y equals 1. So you're actually integrating from y equals 0 to y equals 1. So that will then take us to here. That will then take us to here. So now the hard part's been done. We've changed our order of integration. So now it's just a matter of integrating this. So when you integrate this with respect to z, you can treat this whole thing as a constant. So it will be a constant z from 0 to y cubed. So put this into the z, which is here. So it will get cancelled out, leaving you with just one y, this y here. And when you put 0 into the z, the whole thing disappears. So that will then take us to here. And then let me think. And then now we've got to integrate this with respect to x. So x only exists in this place. So when you integrate with respect to x, it will then give us this, from 0 to natural log of 3, from 0 to natural log of 3. So when you put this into the x, that would be e. I'm going to push the 2 up here, so it will look like this. So basically it becomes 9. Okay, so that will then give us this 9 here. Anyway, that will then take us to, and when you put this into here, when you put 0 into here, this thing here will be 1, and then it's blah blah. It would take us to here, and then now integrate it with respect to y. But before you do that, notice that this block is exactly the same as this block. So 9 over 2 take away 1 over 2 would be 8 over 2, which is the number 4. Okay, so that will then take us to here. So now integrate this with respect to y. So when you integrate this, you're looking for something in such a way that when you differentiate it, it gives you this. Make this to be your initial guess, pi y squared. Make this to be your initial guess. Well, do whichever method you want. When you integrate this, it will then give you this, from 0 to 1, from 0 to 1. And then put 1 into here, put 0 into here, it will then give you this. Your overall answer will be the number 4. That's your final answer. Okay?